Okay, so this is the second part to your notes. Waiting to get it on your screen. And there you go. So on page 1, I put in some picture examples of what it would look like in the base 10 place value system when we throw in a decimal. Okay? So we should all be on the front page of the handout I gave you, which is Journal 5.2a. So the number system that uses 10 digits 0 to 9 and relationships between places are based on multiples of 10. So in 4th grade, you learned about moving to the left being 10 times greater and moving to the right being 1/10 the value when you look at a place value chart. Okay? So in the fill in the blank here, we're going to put moving left across the places. The values are what? 10 times the position to the right. Very good. So again, I gave you a picture example of what that looks like. So if we were looking at a place value chart, like the one placed here on the bottom, every time we jump from the right position to the left position, the number is 10 times greater. Okay? So moving left to right, your position is 10 times greater. What that means is, as you can see in the example here, that as we jump to the left, we multiply that digit by 10 to get the value. So we go from 1/100th times 10 to 1/10. 1/10 times 10 to 1. 1 times 10 to 10. All of these following in the place value listed on your picture example. I know the picture example is quite blurry. That's what happens when we have to take it from a PDF picture to a document and then print it. It kind of blurs everything. But if you look at this, this is your decimal. These are your tenths. These are your hundredths. As we're moving to the left, we are multiplying by 10 and getting a value 10 times greater than the digit to the right. Thumbs up if you understand that. Okay? When we multiply a number by what? It increases the place value of each digit. Jacob. 10. Okay? So if we take 10 times 4, like all this in a bracket, we would get 4,000 times 800 times 90 plus 3 times 2 and 1/10. That number ends up being 489.32 times 10, which is 4893.2 times 1. Okay? So those are just examples of what multiplying that number by 10 increases the value of each digit to. Now, if we're moving right across the places, the values are what? If you're moving right, you're dividing by 10, so they are 1/10 the value to the digit on the left. Again, a picture model showing you that. So here, even though it's blurred out, these are all dividing by 10. When we divide by 10, if you look at it in a fraction value, this is simply going to be the number that you're dividing over 10, which is how it is 1/10 the value. So when we divide a number by 10, it decreases the place value of each digit. And again, I've left you 2 examples to take a look at how that ends up. All of this again is a review of 4th grade material, only this time we're doing it with decimals because we've already done the whole numbers in 4th grade. Questions on that? On the back, all I did was give you another example of what we went through in the journal with the place value chart. So you've got the standard form of a number with a decimal, the word form, which is when every single word is written out, even the numbers, the verbal description, which she gave us as written form, 700 millions, 910 millions, etc. You've got your expanded form. Remember that expanded form is only if the digits are in order by place value. If it's just randomly adding these numbers together, it is simply an addition expression. But if it is adding these numbers together by place value in order, it is expanded form. And again, expanded notation is just taking the value of each digit times the value of its place, okay? So again, another visual description of all the forms of a number for you.